this fall. Okay. Let's do a little bit more on quadratics just from what I know you're going to need to know. In other words, there are some things that I know absolutely certain you're going to need to know, and quadratics and factoring is one of them. Okay? Let me just back up for a moment and make sure that you know how to go both ways here. The start of factoring is really being able to multiply one linear term by another. In other words, factoring is just going backwards from this. But this is actually more important. You absolutely have to know how to multiply those two terms together. So do. Okay, what do you get? First is that's 10x squared. Okay, FOIL. Do it in the same order always. That's one of the secrets of math, is making sure you don't do it randomly in whatever order you feel like at the time. Part of FOIL means first, that was the F. Outside means the two outside terms. What's 2x times plus 2? What is 2x times 2? Okay, and it's a plus 4x. Now, the two inside terms are those two terms. Multiply those together, what do you get? And finally, the last two terms are those two terms. What do you get? Okay. Now, these two terms are always going to be able to combine. Okay. And in this case, they combine to 31x minus 14. So this is the answer. Now, if I gave you what I have circled to start with and didn't give you any of this other stuff, and I said, okay, you start with this, how do you break it up? That's what factoring is. That's all it is. But it's useful to know that, okay? Now, there's a couple things that just happened that I want to go over because this is, you have to know all these rules. If I tell you 2 to the third times 2 to the fourth, what is that answer? 2 to the what? Add the, yes, you add the exponents. If, and it doesn't matter whether it's, in other words, it could be 5 squared times 5 cubed. What's that? Correct. In other words, as long as the bases are the same and you're multiplying, you add the exponents. You do one level less. Okay? And that's really the rule to remember, is you want to do one level less. So tell me what this is. Now I'm dividing, but same base. So what am I going to do to the exponents? you subtract them. You always do one level less than what you're doing to the base. The base is being divided. So I know I'm not doing division with the exponents. Just rule that out immediately. Okay? And there's one last rule, and that's really all there are, is these three rules, where if I have 3 to the 4th power and I do a double exponentiation like that, what's that equal to? Yes. In other words, I'm going to multiply those two exponents, and multiplication is one level less than exponentiation. So that's the only three rules you need to know, okay? But you need to know them for sure. It's kind of like factoring. You're not getting through algebra without knowing how to do these. So it's kind of what I'm going to do with you until we get to a point where I can't think of any other things, is I'm going to go through stuff that I know for sure you got to know in algebra. Okay? All right. And I'll try to do it in some order, and I want to do it to test you also. Okay, so let me just give you a little bit of a test here. Is that equal to? Seven to the 9th power, or 7 to the 9th. Okay? About what are you going to do with the exponents? Okay, what's the exponent on the bottom number? The denominator. It's a 1. So it's 5 to the 8th. And what's that? Okay. And finally, what's that? It's a trick question. We don't know what that is. In other words, I switch the bases on you. If the bases are not the same, you cannot use one of those three rules. Those three rules were either add the exponents, subtract the exponents, or multiply the exponents, only apply if the base is the same. Okay? Now, there are two other situations that you can use if the base is different. And let me just go over those. In other words, here I have the bases are different, but the exponents are the same. So what do you think that is? And you can simplify that. This is like these two rules you also need to know. That's what it is. In other words, if the exponents are the same and the bases are different, then you can operate on the bases and leave the exponent the same. Same thing as this. 4 to the 6th divided by 2 to the 6th. Again, bases are different, but the exponents are the same. So I can just divide the bases. That's the same as 4 halves to the 6th power, which is the same as 2 to the 6th power. That's it. That's your rules of exponents that you're going to need to know at some point in time. I don't know when on some of these things, but I mean, I tutor SAT and ACT, and this is one of the few tips that we do give during the presentation, is this rules of exponents. It's like the first one we give. So you need those rules of exponents. All right. Let's get back to factoring. Okay. Again, let's talk about the order which we're going to search. We're going to start by looking for greatest common factor. If we exhaust that, in other words, if we take all the greatest common factors out that we can, then we're going to look at dopes. And if we don't see dopes, then we're going to do quadratic factoring, which is where you have the 2 parentheses. And if you cannot do quadratic factoring, you got to do the quadratic formula. And I don't know if we'll get into that yet. But it's useful to know the procedure here. Okay, so let me give you some. Remember, what these are is the product of 2 things that are being multiplied together, and what you're really trying to do is unmultiply them. Okay? Start at the top, work your way down. Is there a greatest common factor? Okay, what is it? What's the next line that I should write? What goes inside the parentheses? What you basically want to do is just divide both those terms by 2. In other words, you're correct that 2 is the greatest common factor. So just divide both terms by that greatest common factor, and that's what goes in the parentheses. So what's that? And what's this? It's 25. For it to be 30, that would have to be 60. Because 2 times 30 is 60. And if you do this by long division, even if you just use the long division on your first step, you'll see that 2 goes into 5 only 2 times, not 3. And then multiply it. Okay. All right. Now, we've separated it into 2 times x squared minus 25. What's the next step? Can I factor that further? When they want you to factor something, they want you to factor it all the way down, if it can be factored all the way down. In other words, don't stop. If we were to stop now, we wouldn't have finished factoring it, because this can be factored further. What's the next thing? I've taken the greatest common factor out. I can't do any more of that. How about dopes? Can I apply dopes? Difference of perfect squares. That is a perfect, whoops, hold on a second. I meant to have a pencil. That's a perfect square, and that's a perfect square, and they are being subtracted. So it is the difference of perfect squares. Okay, can't ignore the 2, but I'm going to separate the x squared minus 25 into 2 things multiplied. What are the 2 things? Well, the way you get them is once you recognize that it's the difference of perfect squares, put the perfect squares in there. In other words, what's the square root of x squared? X. What's the square root of 25? 5. Once I get the first term, what's the next one? Yeah, in other words, the first one's the only one you need, because the next one requires no thought at all. Just writing the conjugate as the next term. Okay, so now I've taken my 2x squared minus 50 and I've broken it down all the way to there. Okay, so sometimes you're going to be using a combination of these 3 things. Yeah, I'm going to leave those up there. So. Now, greatest common factor is always the first thing you use. It's always the first thing you look for, because it will always make it simpler if you do that first. Okay? Let me give you one. Got to think for a second here. Hold on. All right, let's start with that. I think I got this right here. Let me think for a second. No. Yeah, I think I do have it right. Okay. It's hard for me to think in reverse here, but that's what I usually have to do when I'm making up problems. So I got to figure out what this factors into first. So what's the first thing I do? Go through and check off your boxes. So is there a greatest common factor there? Can I take one out? What is it? Don't forget the variable. Can I take out any x's? Exactly. That matters a lot. Okay, what's left over? Okay, hold on. What we're going to do is divide that by 4x. What's that equal to? It's okay. Okay, the 4's cancel. What's x to the third divided by x to the first? It's x squared. There's a 1 right there. Remember, you're subtracting the exponents. So that term is x squared. Okay? Now divide that also by 4x. What do you get? Negative. Can't forget that negative sign. And finally divide that by 4x. Yeah. No, the x's cancel. That's x to the 1 divided by x to the 1 is x to the 0, and anything to the 0 power is 1. So x divided by x is 1. Just like 4 divided by 4 is 1. Y divided by y is 1. Okay? So now we have it to the middle step. Now if we look, we can see that I can't really take any more greatest common factors. I've taken the biggest one I can find out, okay, which was 4x. And usually, once you take a greatest common factor out, if you get the biggest one, then you won't be able to take any others out. So usually that's a one step right there. You just got to find the biggest one. If you don't find it, then there's a second step where you find another one. And that's okay, but it's most efficient to find the biggest one to begin with. Okay, now, second check mark. Dopes. Is there any dopes going on here? Correct. There are not. We got a perfect square here, but nothing else is a perfect square. 3x is not, and 10 is not. So there's no difference of perfect squares there. Even if that 10 was a 25, it wouldn't be dopes, because we got that 3x in there. Difference of perfect squares has to be exactly that. It's two terms, both of them have to be perfect squares, and they have to be being subtracted. So there's no dopes here, which leaves us to quadratic factor. Now, because, ignore the 4x for a moment, and let's just focus on the x squared minus 3x minus 10. Okay, so let's do this. I know that's going to be factorable. I don't want to forget my 4x, so I'll bring it down like that. But now let's focus on this. How do we split that up again? And we're just going to keep going through this until you remember the method, because you really have to be able to factor. You just have to. Okay? And I mean, I don't mean to, belabor a point, but you can't really go forward until you remember how to factor. There's various techniques. What I'm giving you, and in fact, the only thing I've given you so far, are what I call first level quadratics. In other words, the easiest kind. But this is the only kind you really, really have to be able to do. The second level ones, I'll show you what they are, but if you had a question on 10 algebra problems, 9 of them would be first level and the 10th one might be second level. Okay? So let's get you to a point where you can master the first level ones. And the first level ones do not require anything exotic at all. They don't require the California method, the diamond method, none of those. They require my method, which is either 3 or 4 steps. That's it, maximum. Okay? This one is 4 steps. Whenever there's a negative sign there, it's usually going to be 4 steps. If that was a positive sign, it would be a 3-stepper. Okay? What's step 1? Split the x's up. How do you split up x squared? In other words, whatever I'm going to write there, the f of FOIL means I got to multiply it by whatever I write there. And their result has to be x squared. So that has to be an x and that has to be an x. It's the only way you get x squared. Okay? So the first step is always the easy one. Splitting up the x's, especially on the first level ones. There's only one way to split up x squared. If it was 2x squared, then one of them would have to say 2x and the other one would have to say x. But if it's x squared, and this is what I'm calling first level, then it always splits up to x and x. So the first step is always the same, never different. Now, what's the second step? In the second step, the most critical thing is the sign on that constant. The constant is 10. Constant is the number that doesn't have an x with it. Okay? And the next step is to what? Figure out what? Both of them. Not just one, both of them. What do both signs have to be? Yeah, they got to be opposite. Okay? So I could write plus minus or minus plus. It turns out it doesn't matter. As long as it's x and x, then the minus plus is the same as the plus minus. So I'm done with step 2. Now what's step 3? This is the hardest step, but not that hard. And I'd like you to verbalize it, because I found that if I can get students to verbalize it, you're going to remember it easier. I'll get you started. Factors of what? Now it's factors of 10, factors of the constant, that have to do what? They have to subtract. They have to subtract to the number 3. Forget the negative in front of the 3 for a moment. I find it's easier to memorize this if you just deal with the absolute numbers. I'm not looking for factors of negative 10. I'm looking for factors of 10 that subtract, because of the negative sign in front of it, to the number that is in front of the x term, which is 3. Not negative 3, but 3. Okay? So, first of all, give me all the factors of 10. 10 and 1 being one set. Don't need to go any further. There aren't any others, but we just found our answer, right? Remember, I'm looking for factors of 10 that subtract to the number 3. Well, that's 5 and 2. 5 and 2 subtract to the number 3. Okay, so I've got my 2 numbers, and now is where I need the 4th step. 4th step is figuring out which number goes with the negative sign and which number goes with the positive sign. You remember the rule on this? Actually, the bigger factor, which is 5, goes with the sign of the middle term, which is minus. So the 5 has to go with the minus, which makes the 2 go with that. Now, you don't always have to do this, but this is not a bad idea to do, is to check your answer. Okay? Now, there's 2 ways I could check the answer. I could multiply x minus 5 times x plus 2 and make sure that I get x squared minus 3x minus 10, right? But the fact of the matter is that I never get it wrong the first term or the last term, because of the method that I used. I'm not splitting up x squared incorrectly. I'm not making a mistake there. And I'm not making a mistake on factors of 10. It's not that hard to factor a number. Where the mistake might be made is in this middle term right there. And that term comes from the O and the I. There's the I, the inside terms, and the outside terms. Remember, these always combine, so multiply them. That's minus 5x. X times plus 2 is plus 2x. And then add them together, which is what you do when you FOIL it. And you get minus 3x. So, is that the middle term? Yes, that means we did it correctly. So you don't always have to totally FOIL it back together again. But if you're not positive, if somebody is saying, you know, would you wager your life on that being the correct answer, you're going to at least multiply the O and the I. You'd probably do the whole thing. But, you know, if your life was dependent on it. But what I'm saying is that if you just check the inside and the outside, that's a good way to check it. And so there's our answer. I can't factor it anymore. I've got 3 linear terms. That's a linear term, that's a linear term, that's a linear term. Linear term means the only x power is to the 1. There's no x squared, there's no x cubed. Just x's. And that's usually what you're trying to do to a complicated quadratic like that, is to separate it all the way down into all of its linear terms, which is what we did. All right. Now, let's take it up a notch. I don't want to spend a lot of time on this, but I want to at least show you how it's done. And this would be quadratics that are not first level. We'll go back and do some practicing on more first level quadratics, but I just want to introduce you to second level quadratics. Here, I'm going to have to play a little bit just to figure out what numbers are needed here. That may not be it. Let me just check for a minute. I think that'll do it. All right, let's make it slightly easier. Hold on. There we go. All right, so what's the first thing you're going to check for when you see this quadratic? Is there one? Okay, what's the second thing you're going to check for? Is there one? Okay, so we're left to quadratic factoring. Now, the only thing that makes this second level is the fact that I've put a coefficient in front of the x squared term that is not 1. And that changes everything when it goes to factoring it. So I'm just going to kind of go through this on one of these just to show you what it is, and then maybe next session we'll try another one or so. But the first step is the same. You have to split up that term. In other words, that term is going to come from this first term multiplied by this first term. So what do these two terms need to be? X and x doesn't work. X times x is x squared. We need to have something that multiplies together to be 2x squared. No, right there. In other words, the only thing that has to be true is these two terms have to multiply to be 2x squared. And they do. Notice that there's a 1 as the exponent. So it's 2 times x to the first times x to the first. That becomes 2x to the second. Okay? So the first step, just as easy as first level quadratics. You just got to split the x's up. It can get harder sometimes. If that was a 4 instead of a 2, then there actually would be 2 ways to split it up. You could split it up as 4x times x, or you could split it up as 2x times 2x. So it becomes more complicated the more factors of that number there are. So I'm really giving you here the easiest possible second level. Okay? The second step is the same also. Determine both signs. What do both signs have to be? Yeah, first of all, they have to be the same. because you can't get a plus sign there. When you multiply these two things together, the only way you can get a plus sign is if it's minus times minus or plus times plus. So the thing this plus sign tells me is that both signs have to be the same, not opposite. And to figure out whether it's minus minus or plus plus, again, I look to the middle term. That's a plus. That makes it plus plus. Okay? Now, here's where the method changes significantly. I no longer can make statements like factors of 5 that add to the number 11. It doesn't work like that anymore. Okay? It's definitely got to be factors of 5 because you have to produce that plus 5. You can't produce that plus 5 if these two numbers don't multiply to plus 5. And there are only one set of factors for 5, and that's 5 or 1, or 1 and 5. And now the process becomes trial and error. In other words, at this point, because I don't have any rules like you have with elementary quadratics, I can't say factors of 5 that add to 11 or subtract to 11. You can't do it on these kind, okay? So by trial and error, I mean I'm going to try 5 there and 1 there. I'm going to see what middle term that produces. If you don't follow me here, stop me because I need you to follow what I'm doing there. That would produce that as a middle term, right? So that doesn't work. So it's not 5 and 1. Well, let's try 1 and 5. In other words, I'm going to put a 1 here and a 5 there. And that's going to produce a different middle term because of the fact of this 2x versus just x. But if I look at that middle term, what's that middle term give me? What's the end sides? It's the outside. Add them together, what do you get? And that is our middle term. In other words, that's what we started with. That's the answer. This is the correct way to factor it. So, step 1 is the same, step 2 is the same. Step 3 is slightly different. Step 3 is trial and error. You're not going to have to do a whole lot of these kind, but you will have to do some. And this is where if they've taught you, or they may teach you, exotic methods that have the names like California method or diamond method, you might have seen something like that, where I would put the number 5 there and 1 there and figure out what goes there and what goes there. They're very complicated. I hate both of them. I try to avoid even teaching my students them because I feel like it confuses them. Unfortunately, some of them, they have to show the method. Now, in Algebra 2, you're probably not going to have to. If you were going to be taking Algebra 1, you may have to show the method. But by the time you get to Algebra 2, if you can factor something, that's all they care about. They're not going to force you to show what method they use. Okay. Now, let me change this problem just slightly to show you how much harder these can get. If I just change the sign on that number, the constant, to negative, well, that introduces some problems. In other words, I still know that it's 2x and x, right? But now the signs have to be opposite because of that negative 5. And unfortunately, plus minus is not the same as minus plus. So I have to allow for both. And the way I do it is like this. And now there's 4 possibilities. In other words, I can put the 5 on the left side with the plus sign and the 1 on the other side with the minus sign. I can put the 5 on the left side with the minus sign and the 1 on the right side with the plus sign, or I can reverse it. And so this is slightly harder because I've got more combinations. There's more trial and errors. In other words, I can either put a 5 there and a 1 there, or a 5 there and a 1 there, or a 1 there and a 5 there, or a 1 there and a 5 there. So there's 4 combinations. And that's given that minus 5 only has 2 factors. If that was like a minus 12, which has 12 and 1, 6 and 2, 4 and 3, it's got 3 sets of factors, then these problems get hard quickly. And they're not going to give you those, certainly not at the beginning of Algebra 2. In other words, the ones they'll give you, there's only 1 set of factors for the 2, and there's only 1 set of factors for the 5. So it's relatively easy to figure these kind out. When they start giving you multiple sets of factors, then you might have 16 possible combinations that you have to try. So it can escalate quickly, okay? But, like I said, don't want to spend a whole lot of time on those second level ones. Let's go back to first level and spend the rest of our time just kind of reviewing factoring and exponents. I'd like to see you master both of these before we go on to other stuff. So let me give you some common quadratics. Let me think. Factor. And I don't have to turn this into an equation. I don't need equals 0. They're going to give you both kinds, where they're going to give you an equation and they say solve the equation, and in order to solve it you have to factor it. Sometimes they're just going to give you a quadratic expression, which is what I've given you here. They want you to factor it into two things that when multiplied together equals that. First step. Okay, are there any? About dopes. Okay, so we're down to quadratic factoring. First step of quadratic factoring. Second step. Third step, verbalize it. It's 2 numbers that multiply to 10, but the way to say that most efficiently is factors of 10. So that's the way you want to think of it also, is the most efficient. You don't really, I mean, when you say factors of 10, you want to know what that means, but what that means is 2 numbers that multiply to 10. So factors of 10 that do what? Okay, what 2 factors would that be? Yeah, and it doesn't matter whether I put the 2 on the left side or the 5 on the left side. I'm going to get the same answer regardless. Notice that if I check it, I get a 5x there, I get a 2x there, add them together, gives me plus 7x, easy peasy. Okay? So, these are all going to be just quadratic. So for the moment, you can forget about greatest common factor or dopes. Step 1. Just always go through all the steps one by one until you get it mastered. These are all going to be quadratic. You can ignore the greatest common factor and the dopes for these few problems. I mean, you can't always. When they give you an expression, you do want to go through those 3 steps. I'm just saving you a little time here and telling you that none of these are going to have a greatest common factor or dopes. They're all going to be quadratic factor. If they were both negative, those 2 negatives would multiply to give you a positive. So that can't be. So the next step is really to examine the sign on that constant, always. That's really your second step. But looking at that sign is what tells you what both signs are going to be. So what are both signs here? Yeah, and because it's x and x, it doesn't matter which way I write them. I could write it minus plus or plus minus. Third step. Verbalize it. Okay, I'll go with that. Factors of 25 is what that means. Yeah, that do what? Perfect. So let's examine factors of 25. What else we got besides 25 and 1? Okay. Anything else? No, that's it. So which set of factors subtract to the number 24? Okay, there's our set of factors. Now we got to figure out where to put the 25 and where to put the 1. Perfect. Because it's the bigger factor has to match the sign of the middle. Because notice why. That bigger factor is going to produce the sign of the middle. Add those 2 together, you get minus 24x. So that's why the biggest of the 2 factors has to always go with the sign of the middle. Let me think here on what I'm trying to illustrate. Yeah, we'll do an easy one. I just want to repeat this to the point where you've done it 3 or 4 times in a row and you know the sequence of steps every single time. Begin. That do what? Not to x, to 1. Give me all the factors of 12. Notice I put the 3 on the left because what I'm doing is cutting that 12 in half and I'm cutting the 6 in half. Because I cut the 6 in half, I have to double that. 2, so that's 4. And that's it. So which set of factors do I want and where do they go? Perfect. Perfect. Now once you get good at these, you won't need to check them. Okay? Until you're really good at them, it never hurts to check them if you have the time. And put the sign in front. If you ignore the sign, you can frequently make a mistake. Because I'm adding these two together, I get minus 1x, which is the same as minus x. That's what we started with. That's correct. Now, when you get to second level quadratics, where there's like a 2 in front of that, now this is an integral part of the process. That's no longer just a check. That's the way you figure out the answer. So it's really good to understand what this, I call this the double smiley face method, because I got a smiley face and another smiley face. Okay? But when you're doing these first level quadratics, that's just a checking mechanism. But when you're doing anything higher, that's part of the process of figuring out the answer. All right. Let's just review some other stuff. Okay, good, because it was a trick question. But if I put parentheses around that, now what I'm doing is 5 to the 5th, all to the 5th power. So what's that? Yeah. And just for interest's sake, you'll like this. When they talk about the largest numbers that you can talk about, and that might seem like a stupid thing to say, because you'd say, well, infinity, and then can you name a larger number? Yeah, infinity plus 1. When they talk about practical numbers, the largest ones you can talk about, like number of molecules in the universe and stuff like that, they use this kind of notation. And they use the number 3. Now, if I put parentheses around that, what's that? Yeah, not an extraordinarily big number, right? But if I don't use parentheses, you have to start from the top down. In other words, I have to do that first. So this thing ends up being 3 to the 27th, which is like 17 billion. So there's a gigantic difference between using parentheses. This is a number I can actually probably name or write. Whereas this, I'd need a calculator for sure. I mean, I need a calculator for both of them, but clearly one is hugely different than the others. And notice this doesn't work so well with 2. If I do this and compare it to this, well, this is 2 to the 4th. That's 16. Big deal. This is, if I do top down, that's 2 squared. That's still 2 to the 4th. Still 16. So they don't use the number 2, they use the number 3. And when they're talking about big numbers, this can go on many ways, and they use an arrow sign like this. That's what that means, is this. And if you use double arrows, then it's 3 to the 3 to the 3 to the 3, and you can get big numbers really fast. But notice how you can grow fast with 3 and you don't with 2. 2 just doesn't do it. So there's a fundamental difference between 2 and 3. But this also illustrates why you need that in parentheses. In other words, I cannot use the rule of exponents on that. But if I put that in parentheses, now I can. 3 to the 14. All right. That's a pretty good section. That's probably a good place to stop. And I definitely feel like we made progress tonight. I feel like you can do a simple quadratic, a first level quadratic, you can do it, even if it's a 4-stepper as opposed to a 3-stepper. And you want to remember how to do that. And we'll go over it every now and then. I'll find different stuff to work on next time. I've got plenty of documents that I can look at. Like I got one right here that I believe is just an Algebra 2 exam. So if we're looking for problems to do, I've got tons of them to look at. But for sure, you need to be able to do exponentials and quadratic factoring and greatest common factor and all of that stuff. But once you master that, then we'll get on and we'll talk about some other stuff. Okay? All right. You have a good week. I'll talk to you next time. All right, Brent.